everybody. This is Math 026 for Hartford Community College. This is Module 2, Part 1. In this module, we will look at rationalizing denominators and radical equations in Part 1, and then applications of radicals in Part 2. So we're going to start by rationalizing a denominator. And when we rationalize a denominator, we are going to take an algebraic expression containing a radical expression in the denominator and write it in an equivalent form without the radical in the denominator. So basically, like negative exponents, we don't really like those in math, except for maybe in scientific notation. And they always ask you to rewrite it without negative exponents. Here, if you have a radical in the denominator, it is not liked, so you change it, or you get, they want you to rationalize that denominator so you do not have a radical in your denominator. So we're going to take a look at how to do it. There's two different ways that we will look at. First is a denominator that contains only one term, and then a denominator that contains two terms, and how you solve those a little bit differently. So for example A, we have the square root of 6 over the square root of 2, and we want to remove that square root of 2 on the bottom. So basically we want to get rid of the radical. If you have a square root, it's not too hard to do. Really, what we're going to do here is to get rid of the square root. Remember your square of a square rule. And I am going to multiply this bottom by the square root of 2, because when I do that, that will give me the number 2 so that I can remove that radical. So I'm going to multiply the top and the bottom, because whatever I do to the bottom on that fraction, remember you have to do the same thing on the top. So remember, if I multiply two radicals with the same index, you just multiply those numbers underneath. So on the top we get the square root of 12. On the bottom, the square root of 2 times the square root of 2 is equal to the square root of 4. But I do know that the square root of 4 is equal to 2. Now, you could write out the square root of 2, or the square root of 4, and then make your 2. Or you just know that the square root of 2 times the square root of 2 will give you 2. Anytime you take and multiply two square roots together, if they're exactly the same, your answer will be whatever is underneath that radical. Now, the square root of 12, you do need to simplify if you can. And the square root of 12, I know I can simplify that because I know that the square root of 4 times the square root of 3 will give me 12. 12. So I'm going to simplify that radical up top. The square root of 4 is 2. So we have 2 square root 3 over 2. And we can do some final simplifying here for this one, because I do know those 2's will equal a 1. So my final answer here would just be the square root of 3 when I rationalize that denominator for the square root of 6 over the square root of 2. Now for B, we are going to first start by breaking up this problem. So we are going to make it so that we have that denominator isolated. So we have the square root of, I'm going to do the square root of 49 over the square root of x. And you can, remember with your rules with radicals, you can split it up into 2. And what I am going to do here is now to get rid of that denominator on the bottom. First, because I do see that at the top, the square root of 49 I know is 7. So I'm going to start off and I'm just going to rewrite it like this to make life easier. Now, it's a square root, so remember to rationalize that denominator, we're going to multiply it by the same thing, so the square root of x, but whatever you do to the bottom, you have to do to the top. So that is going to give me, and we're really going to focus on this problem right here, my answer would be 7 square root x over, now we're going to get the square root of x squared, but we know we can simplify that and it becomes x on the bottom, and we have 7 square root x on the top. Now, that problem is simplified as much as possible because even though I have two x's here, my x on the top is under the radical, so I can't simplify it with the x on the bottom. And then our final problem that we're going to do here is going to be C. So we have 4 over the square root of 8b. And again, I want to get rid of that 8b. the radical. So I'm going to multiply, because it's a square root, the square root of 8b, so times dot. And whatever I do to the bottom, I do to the top. So that is going to give me, I'm going to have on the bottom the square root of 64b squared. On the top, I will have 4 square root 8b, because one's under the radical, one's a coefficient. You just put the two together. On the bottom, the square root of 64b squared is going to be 8b. And on the top, I can do some simplifying with that 8. So remember 8, I know I can multiply the square root of 4 times the square root of 2b. And I just left the b with the 2 because I knew I couldn't simplify it. The square root of 4 is 2. So when I simplify that, I'm going to switch back to, I'm going to go to red and move up this way. I'm going to have 4 times 2, because the square root of 4 is 2, times the square root of 2b, all over 8b. And my final answer will be 8 square root 2b over 8b. Now, hopefully you can see we can do still a little bit more simplifying here. We can see those 8s will cancel. So I end up with the square root of 2b over b. And that will be our final answer there. All right, so now we are going to rationalize some denominators with something other than a square root. So my work here is going to be a little bit different. I want to make my bottom cubed root. I have the cubed root of 2 right here, but I want to make that into a perfect cube. And so if I multiply it by the cubed root of 2 again, I get a 4 underneath the radical, which is not a perfect cube. So what we're going to do here is look at our perfect cubes. Like I know that 1 cubed is equal to 1, which isn't going to help me. But 2 cubed I know is 8. So what I need to know here is what's my perfect cube? I can turn this 2 into an 8. To do that, I have to multiply the bottom by the cubed root of 4, because 2 times 4 will give me that 8, which is a perfect cube. So whatever I multiply the bottom by, I have to do the same on the top. So that is going to give me on the top 1 cubed root of 4, or I could just put the cubed root of 4. I don't need that 1 there. And then on the bottom, I'll have the cubed root of 8. Now, we know the cubed root of 8 is 2, so I end up with 2 cubed root of 4. And that's all we're going to do. We aren't going to change anything there because there's nothing I can simplify, because the 4 is underneath the radical, the 2 is not, so I can't do any simplifying there. So that problem is done. Now, with e, again, because it's all under one radical, we're going to split it up. We're going to look at the cubed root of 3x over the cubed root of 4. And again, I want to turn this into a perfect cube, and I know I can turn 4 into an 8, so that's kind of nice, because now what I'm going to do is I'm going to multiply this by the cubed root of 2, because that'll give me the cubed root of 8. And whatever I do to the bottom, I have to also do to the top. So now I'm going to end up with the cubed root of 6x on the top and the cubed root of 8 on the bottom. But I can simplify that. My cubed root of 8 becomes a 2. And then on the top, I can't really do anything with it. I'm going to have the cubed root of 6x there. For f, again, we want to do the same thing. Let's split it up first. So we're going to look at it as the cubed root of 5y over the cubed root of 3x squared. Now, I cannot turn 3 into an 8, so that's not going to help me. Let's look at our next cube. We have 3 cubed, which is 27. I do know that I can turn that 3 into a 27. I'm going to multiply by the cubed root of 9. And then I also take that x squared. I need to turn it into a perfect cube. Basically, a multiple of 3. So if I have x squared here, I want to make it x cubed so it comes out perfectly. So I'm going to multiply by the cubed root of 9x here, because that will turn it into my bottom. I will end up with the cubed root of 27, because 3 times 9 is 27, and x squared times x will give me x cubed, which will then simplify perfectly. And again, whatever you do to the bottom, you do to the top. So we'll multiply by the cubed root of 9x, which on the top is going to give me the cubed root of 45xy. And then we have to simplify our bottom. I don't believe we can pull any cubed roots out of the top, because 8 doesn't go into 45 and 27 doesn't. So we'll have the cubed root of 45xy on the top, and then on the bottom, the cubed root of 27 is 3. The cubed root of x cubed is x. So we'll have our 3x on the bottom. And that is it. We can't do any more, so we are done with that. Okay, now we are going to look at rationalizing a denominator when we have 2 terms in the denominator. So here we have 2 terms in the denominator. So basically your denominator is an expression. So if we were to multiply by the like the square root of x and the square root of y, it would not eliminate our denominator. So what we need to do to rationalize a denominator when you have 2 terms, or an expression down there, you are going to multiply the numerator and the denominator by the conjugate of the denominator. So the conjugate of 2 terms is simply the same expression, but instead of, like for our first example, we have a plus sign. Instead of using that plus sign, we would use a minus sign. So it's the same 2 terms, but you switch the sign. So if it's addition, you make it subtraction. If it's subtraction, you make it addition. And again, whatever you do to the top, you have to do to the bottom. So we would do that on the bottom as well. So for A, we have the square root of x plus the square root of y. So to simplify and remove that conjugate, or that denominator, we are going to multiply by the square root of x minus the square root of y. And again, whatever you do to the bottom, you do to the top. Now, sometimes on the top, you multiply it out, but right now I would say leave it in factored form, because if we need to simplify later, that might help us. So I'm going to leave the top right now as 4 times the square root of x minus the square root of y. But on the bottom, we are going to FOIL. So we do know that the square root of x times the square root of x, it will be the square root of x squared, which we can simplify later to x. Then we're going to do our outer terms. It would be minus the square root of xy. Inner terms would be plus the square root of xy. And then our last terms would be minus the square root of y squared. And now we're going to simplify that bottom. Again, I'm going to keep my top as 4 times the square root of x minus the square root of y. But the bottom, the square root of x squared, we know is x. Notice these middle terms. I have a negative square root xy and a positive square root xy, so that will cancel. And then the square root of y squared is y, so minus y. So my final answer is 4 times the quantity of square root of x minus the square root of y divided by x minus y. And that would be my rationalized denominator there. I got rid of the radicals on the denominator, so that's what I needed. Now for B, we are going to multiply everything here by 2, but instead of minus the square root of 7, we're going to do 2 plus the square root of 7. And the same thing here. Again, right now I'm just going to leave the top as it is, so I'm going to make it 6 times 2 plus the square root of 7. And then I'm going to FOIL on the bottom. So 2 times 2 will give me 4. And then 2 times the square root of 7 will be plus 2 square root 7. Then we'll have the negative square root of 7 times 2, so minus 2 square root 7. And then our last ones will be minus the square root of 7 squared, or 49. And then we'll simplify the bottom. So now I have 6 times 2 plus the square root of 7. And then on the bottom, remember those middle two terms, when you have conjugates, they will cancel out. So the 2 square root 7s cancel out. And I am left with, on the bottom, 4. The square root of 7 squared is 7. So 4 minus 7, or it will give me on the bottom, when I multiply it out, I will get a negative 3, because I can just do the math there. So I have 6 times 2 plus the square root of 7 divided by negative 3. And then you can see we can multiply the 6 and the negative 3, or not multiply, but simplify it. Negative 3 goes into 6 2 times. So it becomes negative 2 times 2 plus the square root of 7, because one positive divided by negative is a negative. So that will be our final answer there when we rationalize that denominator. All right, and for C, we are going to multiply by our conjugate, and it is going to be the square root of 7 instead of minus 4, plus 4. And we'll do the same to the top, so we'll have the square root of 7 plus 4. And again, I'm going to leave the top as it is for now, because sometimes in factored form it's easier. Sometimes we have to multiply it out, but not for this one, I don't believe. And I always leave it until the end to see. So when we FOIL the bottom, the square root of 7 times the square root of 7 is, again, the square root of 7 squared, or the square root of 49. And then the square root of 7 times 4 will be a positive 4 square root 7. And then the square root of 7 times negative 4 will be negative 4 square root 7. And then when we do our last terms, it will be a negative 16. When I go to simplify, I'm going to have 3 times the square root of 7 plus 4 over the square root of 49 is 7. My middle terms, which is what you want because that's where the radicals are, will cancel out. And then I'll have minus 16. So then my final answer, or the next answer, will be 3 square root 7 plus 4 over a negative 9. And then we can simplify that 3 and negative 9, which is why it's better to leave it in factored form there. So then my answer is going to become, I'm going to divide them by 3. So it's on the top. That 3 becomes a 1, and this becomes a 3. We'll have the square root of 7 plus 4 all over a negative 3. Or you could put the negative at the top. You could have the opposite of the square root of 7 plus 4 over 3. Again, that negative doesn't matter where you put it necessarily. And let's take a look at D. So here we are going to multiply the top and the bottom by the square root, or no, hold on one second, let me erase this real quick. We're going to multiply it by 2 square root x, instead of plus the square root of y, minus the square root of y. And then the same thing on the top. All right, so when we multiply, we are going to end up with, I'm going to do the bottom first, and then because we do have 2 expressions on the top, we probably should FOIL it. But let's worry about the bottom first. Let's simplify that. So we have, we're going to end up with 4 square root x squared. That's 2 times 2 is 4. Square root of x times the square root of x is x squared. And then when we do our outers, it'll be negative 2 square root xy, and then positive 2 square root xy, and then minus the square root of y squared. And on the top, if we FOIL, we can go ahead and do it. It will be 2 square root x squared, because that would be x, and then minus the square root of xy, plus, when I do those inner terms, 2 square root x, and then minus the square root of y. So now on the bottom, when I simplify, my middle two terms cancel out. So I'm going to end up with 4, and then the square root of x squared is x, and then the square root of y squared is y. So 4x minus y, got rid of all my radicals. On the top, I don't have any like terms, so I can't add anything together, but I can, that square root of x squared right here, I can make that an x. So I have 2x minus the square root of xy plus 2 square root x minus the square root of y. And I can't do anything else, so that is all done. All right, so now we are going to look at radical equations and solving radical equations. A radical equation is any equation that contains one or more radical expressions. And to solve a radical equation, the first thing you want to do is you want to isolate the radical on one side of the equation, and then raise each side to the power of the index. So if it's a square root, you would square both sides. If it's a cubed root, you would cube both sides. If it's a fourth root, you would raise both sides to the fourth power. And then you're going to simplify the resulting equation and solve it. And then you do need to check for any extraneous solutions, so any solutions that would not work in the original problem. So the first thing we're going to do is, for A, I need to isolate this radical. I need to isolate the square root of 3x minus 1. So first I am going to add 8 to both sides to get rid of that. So I'll have 2 square root 3x minus 1 equals 18. And then I do want to get rid of that 2 on the outside, so I'm going to divide both sides by 2. So now I have the square root of 3x minus 1 equals 9. And to solve it, again, I'm going to raise both sides. It's a square root, so I'm going to square both sides. So now I have the equation 3x minus 1, because when you square a square root, you just get what's underneath, equals 81. And then I will add 1. It's a linear equation, so I'll add 1 to both sides. So I have 3x equals 82. And then we'll go in here. We'll do 3x equals 82. We'll divide by 3. So x will equal 82 over 3. We do want to check that to make sure it works with the original equation, and make sure it's not an extraneous solution. So I'm going to come over here and work it out. So I'm going to have 2 times the square root of 3, and instead of x, I'm going to plug in my 82 divided by 3 minus 1, and then outside minus 8 equals 10. So the nice thing here is in that radical, we're going to do the work under the radical first. It's like the parentheses. Those 3's will cancel out. So now I have 2 square root 82 minus 1, which gives me 81, minus 8 equals 10. So the square root of 81 is 9. Then we do 2 times 9 minus 8. And 2 times 9 is 18 minus 8. And 18 minus 8 gives me 10. So 10 equals 10. So that does work. So that problem does work. But you do want to check all your answers to make sure that it works. Let me erase my check here so that we can work on the second equation. Now, the second equation is raised to the third power. So again, you want to isolate the radical first. So I'm going to subtract 4. And it's going to give me the cubed root of 6 minus 2x equals a negative 4. And now I'm going to cube both sides so I can get rid of that radical. If you cube the cube root, you get what's underneath that radical. So we're going to end up with 6 minus 2x. And it's going to equal negative 4 cubed is going to give us a negative 64, because we'll do negative 4 times negative 4 times negative 4. Again, I'm resulting in a linear equation. So I will solve it by subtracting 6 from both sides. So now I have negative 2x is equal to negative 70. And then I'm going to divide by a negative 2. So x is going to equal 35. And again, we can plug it back into our equation to make sure it works. So we are going to do the cubed root of 6 minus 2 times 35 plus 4 and see if it equals 0. So the cubed root of 6 minus 70 plus 4 is going to give me the cubed root of negative 64 plus 4. And the cubed root of negative 64 is negative 4 plus 4, and that does equal 0, so it does work. Okay, so now we are going to solve C, which is an equation to the fourth root, or fourth root of an equation. So first we are going to isolate the radical, and we're going to start by, I'm going to subtract 5 from both sides. And that will leave me with the opposite, or that negative fourth root of 7x plus 1. And it will be equal to a negative 2. But then I want to get rid of that negative outside that radical. I want the radical all by itself. So remember, it's a negative 1 there. So I'm going to divide both sides by negative 1. And that's going to leave me with the fourth root of 7x plus 1 is equal to 2. And then I'm going to raise both sides to that fourth root because it is, or the fourth power, to get rid of the fourth root. So we're going to end up with 7x plus 1 is equal to 2 to the fourth power is 16. And then we'll solve it by, I will subtract 1 from both sides. So 7x equals 15, divide by 7. So x is going to be 15/7. And then when you do go back and you do check it in the original equation, it does work. So I'm going to just let you know that that one works, but you do want to make sure you check those extraneous roots. For D, we still need to isolate that radical. So I'm going to start off by adding 1 to both sides. So I'm going to have the square root of x squared minus 5x equals 6. It's a square root, so we're going to square both sides. And then we're going to end up with x squared minus 5x equals 36. Now this equation is a quadratic equation because the highest power is 2, it's x squared. It's different than a linear equation where we just isolate x. Remember, with a quadratic, we want to solve it either by factoring or that quadratic formula. So what we are going to do first is make it equal to 0. So I'm going to subtract 36 from both sides. That's going to give me x squared minus 5x minus 36 equals 0. And let's go ahead and see if we can factor it. I have 36 here, so for 36, my factors are 1 and 36, 2 and 18, 3 and 12, 4 and 9, and 6 and 6. And I need to make a negative 5 and a negative 36. So I'm going to have one positive, one negative. So that 4 and 9 is what I need to use. I need a -5, so that means my 9 will be negative, or minus 9, and then plus 4 equals our 0. And then we're going to set each one to 0, so x minus 9 equals 0, and x plus 4 equals 0. So I'll add 9 to both sides, and x equals 9. Subtract 4 from both sides, x equals a -4. And then we do want to check these to make sure they work. So I'll start off with the first one. I'll do 9 squared minus 5 times 9 minus 1, and we're going to see if it equals 5. So the first thing we're going to do, 9 squared is 81 minus 45, and then minus 1. So 81 minus 45 is going to equal 81 minus 45, let me do the math, equals 36. So we have the square root of 36 minus 1. Square root of 36 is 6. 6 minus 1 equals 5. So that does work. So 9 is a true answer. Let's try our -4. So we have the square root of, and it will be -4 squared minus 5 times -4 minus 1 equals 5. Or if we want to see if it equals 5. -4 squared is 16. -5 times -4 would give me a positive 20. So positive 16 plus 20 is going to give me the square root of 36, which is 6. 6 minus 1 does equal that 5. So -4 works as well. So both answers are true solutions to the equation. Okay, and here we are going to start solving our last two equations for this module. And the first thing we're going to do here with this first one is, again, isolate that radical. So now we need to move that x over. We're going to subtract it from both sides. So now we have the square root of 2x minus 3 equals -x, or the opposite of x, plus 3. We're going to square both sides. So that means we got to square that entire expression here. So on the left-hand side, it's nice. We'll have 2x minus 3. But then on the right-hand side, we have to do the opposite of x, or -x plus 3 times -x plus 3. And that's going to give me 2x minus 3 equals -x times -x will give me positive x squared. And then we'll do -x times 3, so -3x, another minus 3x, and then plus 9 when you multiply your 3 times 3. This is another quadratic equation, so we are going to have to solve it by factoring and setting it equal to 0. So first I'm going to simplify that right-hand side. I have x squared minus 6x plus 9. And then I'm going to move over the stuff on the left. So I'm going to subtract 2x and then add 3 to both sides. I'm going to do it in one move. So that will give me 0 on the left-hand side is equal to x squared minus 8x plus 12. And then we want to solve this by factoring, and we can factor this into 2 and 6. We need two negative signs because it's a minus and then a plus. So it'll be -2 and then x minus 6. And when we set them equal to 0, x minus 2 equals 0 and x minus 6 equals 0. Add 2, add 6 to both sides for the other one. So x is going to equal 2 and 6. But we do need to check our equations. So we're going to start off by plugging in the 2. And we'll do the square root of 2 times 2 minus 3 plus 2 and see if it equals 3. So we have the square root of 4 minus 3 plus 2. So it's going to be the square root of 1 plus 2. And that does equal 3 because the square root of 1 is 1. 1 plus 2 equals 3. So 2 is a solution. Let's try our 6. So we'll have the square root of 2 times 6 minus 3 plus 6, and we're going to see if it equals a 3. All right, so 2 times 6 is 12. 12 minus 3 is 9, so we have the square root of 9 plus 6. The square root of 9 is 3. 3 plus 6 equals 9, not 3. So even though it's a valid answer for what we found, it doesn't work with our equation. So 6 is what we call an extraneous root. So even though it's a solution, it is not an answer to the equation. So our answer to our equation is x equals 2. That's the only answer there. Now we're going to solve f. So what I'm going to do is go ahead and just erase some of this. So take a second if you need to, pause the video, write it down. And I'm going to erase the checking so we have space to solve our equation. Let me erase it real quick. Okay. So now when we go to solve our equation, first we are going to add 3x to both sides. So that is going to give me the square root of 16x minus 3, and then it will be equal to 4x. We're going to square both sides. So that is going to give me 16x minus 3 is equal to 16x squared. You got to square both values there. It is going to be a quadratic again because we have 16x squared. So I am going to set everything to 0. So I'm going to subtract 16x from both sides and then add 3 to both sides. So I have 0 equals 16x squared minus 16x plus 3. We need to factor this. And factoring it will factor into 4x minus 3 and 4x minus 1 equals 0. So then I'll set those to 0. 4x minus 3 equals 0. We'll add 3 to both sides there. 4x equals 3. Divide by 4. So we have x equals 3/4. And then 4x minus 1 equals 0. We're going to add 1 to both sides. So 4x equals 1. Divide by 4. And x will equal as well 1/4. So our solutions here, and I did check them both, and I encourage you guys to do it as well, but both solutions will work in the original equation. So 3/4 and 1/4 are both solutions to this equation. And that is it for part 1 of Module 2. Stay tuned for part 2.